inverse proportion. In our previous video, we have seen what is direct proportion. In direct proportion, when one quantity is increasing, the other related quantity also increases, and when one quantity decreases, the other related quantity also decreases. Now let us see what is an inverse proportion. Let us consider an example in which we will take the speed of the car and the time taken to cover a distance. Okay, let the distance to be covered by the car be 100 kilometers. Okay, now we will take speed of the car and the time taken by the car to cover a distance of 100 kilometers. So when we see that the speed is 100 kilometers per hour, the time taken is 1 hour. When the speed reduces to 50 kilometers per hour, the time taken increases to 2 hours. When the speed reduces to 25 kilometers per hour, the time taken to cover a distance of 100 kilometers is 4 hours. And when the speed reduces to say 10 kilometers per hour, the time taken increases to 10 hours. So what do we see? That when the speed is reducing, the time taken is increasing. When the speed reduces, the time taken to cover a distance increases. And such kind of proportion is called an inverse proportion. So in an inverse proportion, if there are two quantities, so if quantity 1 increases, quantity 2 decreases, and vice versa. Okay, I hope this much is clear to everyone. Now let us just form a table of speed and time. So we have speed in kilometers per hour and we have time taken by the car to cover a distance of 100 kilometers. We have seen that when the speed was 100, time taken was 10 hours. Time taken was 1 hour. When the speed becomes 50 kilometers per hour, then the time taken is 2 hours. When the speed becomes 25 kilometers per hour, then the time taken is 4 hours. When the speed becomes 10 kilometers per hour, the time taken is 10 hours. Okay, now what do we see here? That if we multiply 100 and 1, we get a 100. When we multiply 50 and 2, we again get a 100. When we multiply 25 and 4, again get a 100. And when we multiply 10 and 10, we again get a 100. Okay, so if the instances of speed are say x1, x2, x3 and x4, and the corresponding instances of the time are say t1 or y1, y2, y3 and y4, then we see that x1 into y1, x2 into y2, x3 into y3 and x4 into y4, all of these four products are equal to a constant value k. In our case, that constant value is 100. Understood? So in an inverse proportion, x1 into y1, x2 into y2, x3 into y3 and x4 into y4 will all be equal to a constant value. And where x1, x2, x3 and x4 are the instances of quantity 1 and y1, y2, y3 and y4 are the corresponding instances of the quantity 2. So we see that x1 into y1 is equal to x2 into y2 and this is equal to k. Let us consider this much part of the equality. So from here we get x1 into y1 is equal to x2 into y2. Okay. we bring this x2 down here and y1 down here. So we get x1 over x2 is equal to y2 over y1. And this is the formula which we use when two quantities are in inverse proportion. If x1 and x2 are the instances of quantity 1 and y1 and y2 are the corresponding instance of quantity 2 and the two quantities are in inverse proportion, then x1 upon x2 is equal to y2 upon y1. I hope this much is clear to everyone. We have got this relation because the product of x1 and y1 and x2 and y2 all are equal to a constant. Okay, and the inverse proportion is also represented as, if x and y are two quantities in inverse proportion, then we say that in inverse proportion, then we say that x is inversely proportional to 1 over y. This symbol represents inverse proportion. Inversely proportional to 1 over y. So x is inversely proportional to 1 over y. This sign is the proportion sign. This is a proportion sign, and 1 over y represents the inverse proportion. So this is inverse proportion between x and y. And if we write x is proportional to y, then this is a direct proportion between x and y. Okay, I hope this much is clear to everyone. So let us just quickly take an example. Okay, suppose there are 100 students in a hostel. Food provision for them is for 20 days. How long will these provision last if 25 more students join the group? This is our question. Okay, now let us form the table. The two quantities are the number of students and the days for which the provision will last. So we will have number of students and we will have number of days for which the provision lasts. Let us create a table. It is given that when the number of students are 100, the food provision lasts for 20 days. How long will these provision last if 25 more students join the group? When 25 more students join the group, the number of students becomes 125. And you have to find that for how long will the provision last when the number of students are 125. Now, we know that the instances of number of students will be taken as x1 and x2 and y1 and y2 for the number of days. So our aim is to figure out the value of y2. In inverse proportion, we know that x1 into y1 is equal to x2 into y2. We've just learned that x1 is 100 into 20 is equal to 125 into y2. So from here, y2 is equal to 100 into 20 over 125. 25 fours are, 25 fives are, 5 ones are, 5 fours are, and we get y2 as 16. So this means that when 25 more students join the hostel, the food provision will last for 16 days instead of 20 days. So when number of students are increasing, the number of days for which the provision lasts will decrease, and hence these two are in inverse proportion. Okay, so this is all about inverse proportion. I hope this much is clear to everyone.